What if the largest planet in our solar system didn't have a heart at all? Or worse, what if it once did, and it's now dissolving from the inside out? For decades, astronomers believed Jupiter was simple, a giant ball of gas with a dense, solid core. But when NASA's Juno spacecraft flew closer, the data shattered every rule of planetary science. Jupiter's heart wasn't solid. It was blurry, a strange, diluted core that science couldn't explain. And here's the twist: Saturn might be hiding the same secret. This discovery is rewriting not just our solar system story, but how we understand every planet.
For most of human history, Jupiter was the god of the skies, a radiant, storm-filled giant, too far to touch, too massive to understand.
Even as telescopes revealed its swirling belts and great red spot, one question remained: what lies inside? Early astronomers had two opposing answers. Some claimed Jupiter was a failed star of pure gas. Others were sure it had a rocky, heavy heart. Two theories, two rival visions. Both seemed plausible, until evidence whispered something else. Every spacecraft detected elements that shouldn't exist in a pure gas world: carbon, nitrogen, oxygen, even noble gases. These hinted that Jupiter was mixed with heavier metals, fingerprints of a more complex origin. But how, if it was never supposed to have a core? Science was staring at an ancient riddle. The first explanation was the collapse model. Billions of years ago, gas and dust swirled around the newborn sun. Hydrogen and helium became so dense that gravity pulled the gas inward. Within a heartbeat of cosmic time, a world was born, a gas colossus without a solid center. It made sense, but had one fatal flaw. A planet purely of hydrogen and helium shouldn't contain so many heavy elements. Yet, evidence kept piling up. Heavier materials that didn't belong in a simple failed star. The core accretion model solved that. It proposed Jupiter began as a solid body, a rocky embryo that later pulled in gas. That could explain the metals and ices. But if Jupiter had a dense core, why were gravity and magnetism measurements so vague? No solid object should hide that well. Planetary scientists were trapped between two imperfect answers until NASA built Juno. Unlike predecessors, Juno wasn't designed to take pictures. It was built to weigh Jupiter, tracking the planet's pull on its trajectory. Each tiny change in Juno's velocity revealed how Jupiter's mass was arranged inside. It was a scientific stethoscope pressed against a god's heart. When Juno arrived in 2016, expectations were simple: confirm which theory was right. But space rarely rewards simple answers. The data that came back in 2017 didn't fit either model. Jupiter wasn't built like anything in our textbooks. Instead of a compact ball of rock and ice, Juno found a vast, diffuse region. Heavy elements blended into hydrogen and helium, stretching halfway toward the surface. A fuzzy core. Not solid, not empty, just blurred. Scientists were stunned, yet the numbers didn't lie. So how do you make a planet fuzzy? One bold idea suggested Jupiter once had a solid heart, until something smashed it. In the violent youth of the solar system, a newborn planet might have slammed into young Jupiter, shattering its core and scattering heavy elements. The shockwaves would have mixed rock, ice, and metal with hydrogen, leaving a turbulent, blended interior. It explained the blur. For a moment, scientists believed they had found the answer. But supercomputer simulations told a different story. They showed that after such an impact, gravity would eventually pull heavier materials back down. Jupiter's core should have reassembled, not stayed fuzzy. And yet, after 4.5 billion years, Juno still saw a blur. That meant the cause had to be deeper, not destruction, but creation itself. Here's where the story turns from explosive to subtle. As Jupiter formed, heavy materials partially dissolved into the surrounding hydrogen and helium, forming smooth gradients. The planet's core slowly bled into its atmosphere. The boundary between core and envelope disappeared, leaving a continuous transition. For that structure to survive, Jupiter doesn't fully stir itself. Unlike Earth's mantle, Jupiter has deep, stable zones that don't mix. That means the gradients could survive for billions of years, preserving the planet's blurry heart. Jupiter may have started with a solid core that simply melted into itself and never stopped. Just as Juno was rewriting Jupiter, Cassini was orbiting Saturn, collecting extraordinary vibrations that echoed through its rings. Those ripples acted like seismic fingerprints, revealing Saturn's inner structure. When scientists analyzed the data, the pattern was unmistakable. Saturn, too, lacked a sharp boundary. Its heavy elements were spread out, forming a diluted core. Two giants, two fuzzy hearts. Fuzziness wasn't a cosmic accident. It was a universal pattern. If Jupiter and Saturn formed this way, then maybe all gas giants, even hot Jupiters orbiting distant stars, share the same blurred anatomy. It's no longer the exception. It's the rule. But Juno uncovered another mystery, one even stranger. Jupiter's magnetic field isn't clean or symmetrical. It's lopsided, distorted, and covered with magnetic hotspots. Some maps even show multiple south poles. How is that possible? On Earth, our magnetic field comes from molten iron. Jupiter's should be simpler, metallic hydrogen swirling, generating a clean dipole. But instead, its field looks like it was drawn by a drunken artist. Some scientists think the answer lies in the fuzzy core itself. The mixing of heavy elements might disrupt the normal flow of metallic hydrogen, twisting the currents that power the magnetic field. Others blame helium rain, droplets separating and sinking deeper, altering heat flow. Another theory suggests multiple dynamos, different layers generating magnetic fields that interfere. Whatever the truth, Juno's data showed one thing. Jupiter's interior isn't just complex. It's alive, shifting, uneven, and still evolving. And that means the planet's story isn't finished. Now imagine scaling that mystery to the entire galaxy. Thousands of exoplanets have been found, many of them gas giants larger than Jupiter, orbiting scorchingly close to their stars. We call them hot Jupiters. They're bloated, overheated, and massive. But one detail puzzled astronomers for years. These planets were too puffy, their atmospheres too inflated to match standard models. Until Juno came along. When scientists added fuzzy cores and gradual composition gradients to their models, the numbers clicked. Those blurred interiors slowed down heat loss, keeping the planets swollen and radiant for billions of years. In short, Jupiter had given us the missing piece. Suddenly, the fuzzy core wasn't a strange anomaly. It was the key to understanding planets across the universe. If Jupiter and Saturn share this trait, the same could be true for exoplanets orbiting distant suns. This discovery redefined how we think about planetary formation, evolution, and stability, fueling research, funding, and technology development. Even with Juno's final data in 2025, Jupiter's secrets remain half-told. We still don't know whether the fuzzy core is stable or slowly dissolving. We don't know how its gradients formed so precisely, or how they've avoided being erased by time and turbulence. We don't know how its interior architecture links to the patchy magnetic field, or to the spectacular auroras that glow constantly at its poles, the most powerful in the solar system. But we do know this. Every answer raises new questions, and the more we learn, the more Jupiter challenges the boundaries of planetary science itself. Even now, teams around the world are running new supercomputer simulations, modeling impacts, gradients, and internal waves that echo like seismic tremors through the gas. Some of these waves, scientists believe, could let us listen to Jupiter's heart directly, mapping its interior the way earthquakes reveal Earth's core. If that succeeds, we may finally see what no human has ever seen, the living anatomy of a planet. Jupiter began as a mystery of color and storm. Now, it's a mirror, showing us that even in a universe built on rules, nature still loves exceptions. The fuzzy core discovery changed everything. It blurred the line between solid and gas, between order and chaos, between what we thought we knew and what the universe really is. It forced us to accept that planets, even the ones we've known for centuries, are still rewriting their own stories. And in that fuzziness lies a truth bigger than Jupiter, that science itself is never finished. Because sometimes, the closer we look, the less solid everything becomes. Jupiter didn't just break the rulebook. It taught us that even the most familiar worlds can hide impossible secrets beneath their surface. So now we have to ask, if the biggest planet in our solar system has a blurry heart, what else out there isn't what it seems? Hit subscribe and ring the bell to stay with Oddiverse. where science meets mystery and every discovery reveals a deeper truth. Oddiverse, where the unexplained meets the undeniable.